Today, we're going to dig into the secret reason your web browsing got a massive, and I mean massive, upgrade. You might not have seen it happen, but trust me, you've definitely felt the difference. So let's start with a feeling we all know too well. You've got a blazing fast internet connection. You click on a link and nothing. The page just hangs there, loading piece by agonizing piece. It's so frustrating, right? So what's the deal? Well, for years, the answer wasn't your computer or your Wi-Fi. It was hitting deep in the foundations of the web itself. You see, to really get to the bottom of this, we have to understand that the modern web was dealing with a huge, hidden traffic jam, a fundamental bottleneck that was slowing everything down, no matter how fast your internet was. Okay, so this process on screen, it looks pretty simple, right? When you go to a website, your browser finds the address, connects, and asks for the main page. But here's where it hits a wall. In steps 5 and 6, your browser gets that first file and realizes, whoa, this is just a skeleton. To actually build the web page you see, it needs a whole lot more stuff. And how much more stuff are we talking about? Well, the average web page today needs about 75 extra resources to load completely. That's 75 different images, scripts, style files, you name it. And every single one of them has to be fetched from the server. This, right here, is where that massive traffic jam really started. So get this. The real problem wasn't your internet speed. It was the actual rulebook the web was built on. A protocol that was, to put it mildly, getting really, really old. The web runs on a protocol called HTTP. As you can see, it started out super simple back in '91, basically just for text. But by 1997, we got HTTP version 1.1. And that protocol, that became the engine for the entire internet for almost 20 years. I want you to think about that. The entire interactive, video streaming, social media web that we know was running on technology that was finalized in 1997. And this quote right here is the heart of the problem. You see, HTTP/1.1 could only do one thing at a time. It was a request and response system. As one source puts it, while just one of those requests was being handled, the connection was totally blocked. It basically had a one-track mind in a world that desperately needed to multitask. The absolute best way to picture this is a checkout line at the supermarket. You've got your 75 items, all those images and scripts, but the cashier can only scan one at a time. Every other file just has to stand there and wait its turn. That's exactly what HTTP/1.1 was doing, creating this massive invisible queue for every single website you visited. Now, you have to give them credit. Web developers are a clever bunch. They couldn't just change the rules of the internet, so instead, they came up with all these ingenious but really messy tricks to try and get around that one-at-a-time rule. They did things like domain sharding, which was a way to trick your browser into opening up multiple connections. Kind of like pretending to be different shoppers so you could get into several checkout lanes at once. Or spriting, where they'd basically tape a bunch of tiny images together into one giant sheet so they only had to make one trip through the line. They were clever hacks for sure, but they made websites way more complicated and a pain to maintain. Okay, so before we get to the big fix for this HTTP mess, here's a little piece of tech trivia for you. We've all heard of the internet's addressing systems, right? IPv4 and its successor IPv6. But did you ever stop and wonder what happened to IPv5? Well, it actually existed. It was an experimental thing meant for streaming audio and video, but it kind of had the same old problems as IPv4 and just never really took off. So the world just skipped it and went straight to IPv6. Kind of funny. Anyway, back to our main story. The web was absolutely creaking under the strain of all these hacks, and it was clear we needed a real solution, not another workaround. And then, in 2015, that solution finally arrived. It was time to upgrade the entire highway system of the web with a brand new protocol, HTTP/2. So what was the big game changer? Well, this slide nails it. With the old way, HTTP/1.1, each of those 75 files had to patiently wait in line. But with HTTP/2, all of those files could be requested and downloaded at the exact same time over the very same connection. No more waiting. The magic trick that makes this all possible is a feature called multiplexing. Now, that's a fancy word, but it's a really powerful idea. It's the ability to handle all those requests and all those responses in parallel. It took that single slow-moving checkout line and turned it into a multi-lane superhighway where everything flows all at once. Okay, so that's a lot of tech talk. Protocols, multiplexing. What does any of this actually mean for you just scrolling through your favorite sites every day?
The bottom line is a fundamentally faster, smoother web. Those complex pages with tons of pictures and videos load so much quicker now because all their parts arrive at once, in parallel, instead of just trickling in one by one. It's the reason your browsing feels so much more snappy today, even if you never realized this massive upgrade was happening under the hood.
You see, HTTP/2 was designed to solve the biggest performance problems of its time. But technology, it never stands still. This upgrade fixed the web's biggest traffic jam, but it also paved the way for new challenges and for the next evolution, which is HTTP/3. So that leaves us with one last question to chew on. What problems will the next version of the web's protocol have to solve?